of people still trickling in. Let's see, real quick before we get started, I will make my plug for our DCA forum coming up here in June. For those that may not be aware, this is our 6th annual practitioners, nerds getting together. We've identified kind of 6 topics this year around sort of data-centric architecture that we're going to focus on. Wouldn't be a current conference if we didn't have something about LLMs, but we're going to hit on cybersecurity and entity resolution and a number of different areas as well. So that's in person in Fort Collins here in June. We've got some speaking slots remaining, kind of a limited number of seats. So if you are interested, I just dropped the link in the chat. Questions, feel free to let me know. With that, we have Sebastian here from yWorks this month. Let's see, I'll give a little bit of an introduction. I know yWorks has been on our radar for a number of months, and we talked actually last year about getting an opportunity in here, but you guys have done some pretty interesting kind of development in the meantime that meant this was worth delaying on. Let's see. So as managing director at yWorks, responsible for development of the different tools, the yFiles library. There's a suite of graph visualization libraries, which has been of unique interest to this group for the last number of months. And so they're at 35 employees today, doing a bunch of different graph visualization and interaction techniques. Is it right that this was spin out from sort of the university at one point? So I'll let you get into that a little bit more, but I will watch for hands as we go and chat and kind of flag those. But with that, Sebastian, I'm just going to let you give any more intro you'd like and jump in.
Thank you. Thank you so much for this introduction. I'm going to share my screen now. I hope that you can see it. So first of all, thanks for having me. I wasn't quite sure what exactly to expect today. So if you feel that I'm running into the wrong direction, just give me a give me a sign, and then I'll switch directions. So I have multiple topics today that I was planning to present. And but I can just switch topics if I'm boring you. So let's just see and dive right into this. So I called my presentation "Useful Graph Visualizations and How to Actually Create Them." And when I say useful, what is it that I mean by useful? Let's take a look at this example. So on the left-hand side we have this what I would call raw data. It's not really raw data because it's not fair to say this is a raw data because we have a layout actually. It isn't as bad as it could be. It does have a layout in the sense that it's a simple one, but it has things like clustering. So you can see that there's three clusters in there, and at least it's overlap free, showing some labels. So that's something. But compare this with a recent example that we implemented for the graph drawing contest at the International Graph Drawing Symposium in 2023. So on the right-hand side. And we had been given this data set on the left, which is basically just a list of board games, the top 40 board games as discussed in some social media forum, boardgamegeeks.com, I believe. And the edges are connections that showed how games were rated by the users of that forum. So at the core, both of these visualizations are using the same data. And the image on the right has been created from the raw data that we see on the left. However, what was added was actually like domain knowledge that's not available in the data itself, at least not in some machine readable form. So some of this could be added to the data in the form of like extra ontology information. But what's not in the data and what makes the visualization arguably useful is the question that we're trying to answer with the visualization. So as soon as we have a question, we can actually discuss how to best present answers to it. So let me quickly show you our solution, if you may call it so, to the questions that we wanted to answer with our visualization. So let me just switch to the other browser. So this is the visualization. It's actually not a static one, it's an interactive one, which is one of the points that I'm going to discuss in detail later on. What we see here is that we like try to segment the data into various aspects, and we're actually like answering 3 questions at the same time. One of them is how games are related. So these are board games, and you can see the visualization, like this is the ranking of the board game. So that's place 40 Caverna, and as you can see on the left hand panel, these games belong to the same to a cluster, in this case civilization building, and space and world exploration and so on. So you can see that there are clusters of elements in this visualization. At the same time, we can see the same game, the same entities in these 2 other like isometric panes. You can see that they are actually aligned, so to help the user better find his way around. So if you look at these visualizations, you see the cluster data, and in this visualization, you can see relationships that tell you if you're interested in a specific game and you like that game, what did other users who liked that game like even better? So like people that liked this game over here agreed that this game over here is even better. So this is what this visualization answers. So if you're interested in the game, you can find other games that you're interested in. And the interesting thing is that it's not just like looking at the ranking of the games, and if you like number 14, you'll probably like number 12 even better. That's not true. It's because games are different. Obviously, there's different ways that people rate games and how they like it. So these are the 2 like dimensions that we wanted to highlight. If you like this game, which one you might want to try and see if it's even better. And the reverse is also in there. So if you like this one, you should rather not try the other one because this one is even worse. So the red edges indicate hated more edges relationships, and the green ones are like loved more or liked more. And interesting, they should by tendentially like point into the same directions. All these edges in this direction in this graph, they should point upwards, and this one they should downwards, but that's not always the case. And there's some interesting outliers in there where there's actually people disagreed in both directions and so on. So what we're doing is we are highlighting outliers in here, which is often a use case, and we are answering specific questions. Yeah. So this is what I think is a good visualization. So, but why exactly? Let's go through the various ingredients that make up a good graph visualization. And the examples that I will show you now are taken from the demos and apps that we have built here at yWorks. They most of them come with the yFiles product at the library as code examples. And I realized that some of these examples for data scientists working with like raw knowledge graph data, there often is not a specific use case or a question that might seem worth optimizing for. But so nevertheless, let me start by showing you the types of the insights you can gain or the values that you can provide to your users when you create bespoke graph visualizations. So in the next slides, there will be just an overview, next 5 slides. And after this, I'll show you some solutions and the tools that we created to help you with your visualization challenges. So let's begin with the topic item design. Let's see what options we have for manipulating or specifying the visualization of an item in our graph. And why should we do this? Because we can directly show important information directly to the user just by having the user take a look at the application, not by interacting with the application, for example, by like showing a mouse hover or tooltips or something, or maybe a details panel in the right hand. So showing information directly on the screen is crucial. You should present the essential information But what is specifically essential is obviously something that is up to the question that you're trying to answer. So for some use cases, you're doing this dynamically, so you can let the user decide what information to show. And for others, you know exactly the question and how to present the answer. And then you can, as a developer, decide what information to show right on the screen. So that could be just like text labels, of course, but you can add icons or gauges and progress bars and all kinds of interactive elements. Even things like charts or even forms or interactive UI elements could be presented right inside the visualization of the nodes and the edges. It doesn't have to be just the nodes. It could also be on the edges or in the labels or in the selections, ports, and all this. One interesting thing is the use of level of detail, because if you add too much information to your visualization, obviously you can overwhelm your users. So you might use techniques like level of detail. So, well, to only show more information once the user zooms in onto a certain part of a diagram. And the last bit is interesting. You can, for example, in the example that I just showed you with the board games, you can integrate data from additional sources only during the visualization. For example, in the example that I had, there were like URLs, or maybe it was just IDs given in the data set. And during the visualization, we automatically fetch the covers of the boxes of the board games and add them to the visualization just by combining the IDs with some predefined URLs. Another interesting thing is often many don't notice that when they are using a visualization or when they're about to visualize their data. It's absolutely not a requirement to like depict every item or entry from the data source as a box or a circle in your diagram, or nor every relationship as a line connecting these elements. So the schema of the data might be in a totally different shape. It might have been optimized to work seamlessly with data loading or for certain queries or different visualizations already. So consequently, the current schema in your data might not be the most suitable for your current visualization needs. So moreover, remember that efficient visualization tools can do much more than merely draw boxes and lines. You should really leverage these additional capabilities to enhance the visualization's accessibility. So consider the following. Some relationships are better left unrepresented as lines. So for hierarchies expressed as relationships or node properties in the database, consider techniques like nesting nodes recursively, or the hierarchy can get visualized through containment, significantly removing the clutter from the diagram. And depending on the use case, sometimes it can be more intuitive to display shared property values as connected standalone nodes, or just the other way around. So really change the schema to work with your visualization. Often there are instances when showcasing transitive relationships, which aren't explicitly in the database, provide the insights to users that they seek. So again, this helps to reduce the amount of unnecessary noise in the visualization if you're just showing the endpoints of a transitive, maybe even multi-hop relationship in your visualization. And then again, sometimes it's beneficial to group multiple relationships into one or a few edge bundles, enhancing the diagram's readability this way. So embrace the idea that the visualization doesn't necessitate a direct one-to-one mapping from data source elements to visual elements. And with a good tool, altering the storage or the implicit schema in your database most of the time is not mandatory. And with a little work, these transformations can easily be accomplished at the visualization layer and not on the database or somewhere else. Automatic layout, super important for us, of course, because that's our origins. We as you said, we've been spun off of the University of Tübingen, and what we started with is automatic layout. So don't merely place nodes close to their neighbors on the screen. This is good, but typically far from sufficient. So the placement of nodes and the routing of connecting lines can encode a wealth of meaning. If that meaning is important for the use case, you should really present it clearly. So when your items belong to different categories and those distinctions matter to your users, factor this information into the layout and put the items of the same category closer together or apply an extra layout to them. And when there's a flow in your data, emphasize this flow across the edges using like directed layouts, from top to bottom or left to right or whatever. So if your data contains hierarchies, present them in a manner that users would typically expect them to be, so often top to bottom. So you can move the start and end nodes to the respective sides in the layout so that the user quickly sees the entry and exit points in your flows. And with advanced automatic graph layouts, you can specify many different constraints that assist in highlighting the details, clusters, group, subgroups, and outliers, dependencies, and so on. And the sophisticated edge routing allows users to see the connections even if there are many of them. So you can even consider utilizing multiple layout algorithms with varying configurations to emphasize different facets of the data to the user and then animate smoothly from one layout to another, allowing the user to keep their mental map of the data. And last one, the canvas. What's behind your graph visualization in the background? Just an empty canvas? And it doesn't have to be empty. It doesn't have to remain blank. So for instance, when relevant, place your nodes within a table with defined rows and columns, or alternatively, or organize them into like parallel swim lanes to convey useful categorical information. This can be more effective than merely representing that information as a textual property or adding yet another node and a connection. So even scalar data can be effectively visualized using, for example, heat maps in the background of your graph. And you can render the outcomes of graph algorithm runs into your background visualization. So you can use all kinds of algorithms like centrality measures or shortest path analysis, clustering results, and dependency analysis results, and embed that information in the drawing. You don't have to like calculate those results on the front end. You can do this in the back end, but for example, yFast can also help you with the calculation of these graph analysis algorithms right in the client during the visualization. And of course, if things like geodata is important to your audience, you can just position the nodes on a geographic map. And yeah, so you should really think twice before you leave your background empty in the visualization. So, and the last thing, I said it's also already the last, but it's not the last. No, this time this is the last. An important thing is interactivity, because a static visualization has its merits. Oftentimes the complexity we see in complex data and complex use cases really necessitates the addition of interactivity to make it easier to explore the data and enhance the user experience. So proper interactivity not only makes for a more powerful visualization, but also significantly enhances its utility, in my opinion. So certain interactions are quite fundamental to aiding users in data exploration, like searching for elements or selecting elements, displaying details, providing tooltips, and so on. But interactivity's potential extends beyond these basics. It can be harnessed to let the user interactively explore features of the network, for instance, to identify bottlenecks in the supply chain network or conduct root cause analysis or interactively view upstream and downstream elements in a larger flow. But you can also like enrich the editing experience for users. So if you create a graph interactively or modify it, you can create bespoke interactive user stories, so that really that perfectly match the requirements of your users. So many of these methods actually assist in reducing the complexity of your visualization, and then they keep the user from having to like untangle the hairball, which is a problem that we frequently see with larger data sets. And the solution is not to display the hairball, but to let the user interactively work with the graph to see the information that they are interested in. Okay, so enough with all this theory, and let's see some of the tools in action. So this is just an overview of how the tools are connected. So I'll be showing you these tools on the right-hand side, which are all created using yFiles, which is our SDK that we built here at yWorks, which is our main business. Our main business is creating the SDKs and APIs so that our customers can create visualization applications. But of course, we do eat our own dog food, and so we've created these applications both to give something back to the community, but also to showcase what can be done with our tools. And so there's the free tools that we'll be looking into. The first one is the Data Explorer, and let me show you how to use it. So this is a Data Explorer, and it's specifically made for Neo4j. I think it's not the database that you guys are favoring when you work with databases. So if you're into like more like into Sparkle databases or things, we don't have that publicly available yet. However, last year we have been prototyping a version that can work with Sparkle. So if you want to test drive that version, let me know and I will see what I can do. For now, if you want to use this specific tool, you will have to first like load it into a Neo4j or some Cypher compatible database so that the Explorer can talk to it. So let's take a quick look at some of the capabilities of this tool. So just to make this clear, the thing that is part of yFiles is really just this empty canvas in the background. There's still empty canvas in the background. So everything that's around the canvas is something that we added like on top of yFiles for this demo. And this is typically what our customers do. They don't build demos, but in their applications, they take the canvas and embed the graphing functionality into their components. And so everything you see outside of this canvas is basically not part of the library, but something that we implemented in this tool over here. What does it? It will connect to your database, to your Neo4j database, and it will actually directly connect to the database from within the browser. So there's no server involved, no other than your database and our server hosting the JavaScript, but the connection is directly between my browser instance and the database. So the database could be hosted locally and it will never leave my network. I can actually like unplug from the internet right now and it will still work after it has downloaded the JavaScript to execute. So what can I do? So this is a very, very simple database I have here, and it starts by showing me the schema. I see there's persons in this database and there's also movies, and there's a couple of relationships declared in the database and a relationship between the persons. So there's like a social network in there and some information about which person acted in which movie, directed, produced, or reviewed a movie, or even wrote probably the book of the movie. So this is all super simple in this case because it's a super simple schema. And the interesting part is the Explorer, where I can go and add some of the nodes and fetch them dynamically from the database and then explore them. So let's just start with some random data. I get to see entries in the database. So this is a graph database, Neo4j. So we have these nodes over here and they have properties. I can see the properties for the persons. It's just their age and no, it's the date when they have been, the year they have been born, and their name. But for the movies, there's some more information associated with the nodes, and we can see that information actually right here inside the visualization. other features that I have here, I can like interactively drill down and load other items from the database. And in case there's many results, it will let me choose the ones that I want to see, and then it will incrementally add these elements to my visualization. So in this case, I'm using a hierarchic layout because obviously there's this like persons always ever do something with movies. So we have like a bipartite graph over here. So the hierarchic layout is a good choice. Whereas if I use like this organic one, you wouldn't see much structure in there. So the hierarchic one is actually quite well suited for this kind of visualization. So what else can we do here? We can like run some algorithms. We can export the visualization and for example, to PDF or SVG for inclusion in some Word documents, and we can share it with our colleagues, and we can run Cypher queries interactively. And what's really cool is that feature that we've built into it is to use last year when everyone was using or was going the riding the AI hype wave. We added this into it's almost a year now already too. So what I can do here is, let me just try this. Load movies with Matrix in the title, and then I can send that to the AI, and it will come up with a Cypher query, and it will execute that query. And okay, and it didn't work. Oh no, it's already there. Oh, okay, so I already had those movies in there. So bad example. Let me try another one. So how about another query? Let me check what else I have. I tried. It was like, yeah, like this one. Load actors that acted in all the selected movies. And now this is a more complicated query which I would not be able to like do interactively in the UI, because there's no UI that we created for loading mutual neighbors in the visualization. So we used the large language model to create a corresponding Cypher query, and actually that's like not just made it easier to work with the database, but actually to execute queries that we would have to like enter manually, because the UI doesn't give us this feature by default. So yeah, but let's go to another. So that's the basics of this exploration tool. It lets you explore these elements and run some layouts, and you can query the database, as I showed you, using the context, for example, telling it to use the selected elements at the moment, or like remove the selected items, or select actors born in the 1960s, or things like that, and it will come up with a query and execute that for me. And another feature that we have in this product or demo is, you already saw that we're actually using interesting visualizations in there. So this we show actually some properties, like this is a product, and this product has various properties in here, and the question is, how can you like change the design of these elements in here? And there's this feature in here where you can actually interactively modify the template. So this becomes editable. So if I wanted the title to be down here and this information over there, I could just change that. And so this is actually just data binding, and I could like change the contents over here and get data binding, as you know it, maybe from React and so on. And what's really cool is we have this feature over here where I can ask the AI to come up with a template. The AI will take a look at the schema, and will produce sometimes super nice visualizations, and this time it's a bit more boring. So it came up with the category and the name for the various items, and decided in which order and what elements to show. So let's just try it again and see if we get a different result, because it always works. Yeah, so this is another one, and I can just apply that template, and then I get to see those in my visualization. So if there's multiple products in here, let's load a few orders, and then we get to see all those products with a new template in here. Yeah, so much for the Data Explorer. And so we saw that we can like create specific templates for different nodes, and we can use features like images and shapes or formatted text, and let the AI help come up with the design if we are too lazy with the manual creation of the template. So what else can we do? We can even use like geolocations, for example, if it's available in the data. We can use that to show the elements on a map, and we can run graph analysis algorithms. There's just a few in this demo, and there's other advanced exploration interactions. Let me just show you one of these. So let's switch to another example where we actually have geodata. So I think this one, there's geodata in there. Let's load some entities in here. It's just a single bank. That's a bit boring. Let's load a few more entities. And now these entities, they actually have some geolocation associated with them. So we have another layout in here. That's the map layout, and it will put those. Okay, they are all in the same space, but it would be putting them. It would put them on the map right here, and now we have the problem that all of them are obviously in the same location in the database. And for this, we can use this super interactive tool that will like unclutter visualizations just by like moving this lens over the location, and then it will push them to the outside, and so that I can see the connections interactively and still have the geolocation as part of the visualization. So that's an interesting thing, switching between a logical layout and the geo layout or something else, switching between layouts to reveal different aspects of the data. Okay, so next one. So far we've seen a no-code approach. So I showed you this application that we built on top of WIFI files, and the second option that I want to show you today is also built on top of WIFI files, but it's meant to be used by data scientists, and specifically those who work with Python programming language. And this is about our free Jupyter Notebook plugin. And so I guess all of you know what Jupyter is. So a notebook, for literate programming. So what you can do with it is you can interactively visualize the graphs that you're working with right inside your Jupyter Notebook. So if there's any data that you have access to as a programmer in your Jupyter Notebook, be it from some existing other graph libraries where the graph data structure is available, like NetworkX or iGraph or GraphTool, or even just a pandas data frame or some SciPy data, anything that basically is available as, well, a list of nodes or edges can be turned into a visualization with this plugin. It's a free one. You can just install it with a pip install in your notebook, and then go use it. Just throw some data at it, configure the visualization, and then enjoy some nice visualizations. Let me show you. I loaded the introductory notebook into my local Jupyter Notebook, but it doesn't have to be one. So you could also be using like Google Colab Research or some publicly hosted Jupyter Notebooks, or there's other hosters for similar products that also rely on the Jupyter Notebook widgets. and they should all work with this plugin. So all you need to do is like pip install the widget, and then import the package, and then import the actual widget from it. And then you get to throw some data at it, and let's just do it. So I already ran the installation, so because this takes like a few seconds, then I just execute this cell over here, and now I create an instance of the widgets. Now I specify the nodes that I want. So this is the most basic examples that we have, so which doesn't rely on any other third-party data source. It's just dictionaries and lists in Python, and I tell it to display the results, and this launches the widget. And right inside the widgets, I get this Jupyter Notebook cell. In here, I can like increase the size, and then I have this interactive widget where I can see my graph. I can change some of the layouts, and these are that's the same one. These are the basic layouts available in WAV files. So there's not much configuration you have in here, but it's super useful if you have graph data, because you can do stuff like inspect the neighborhood conveniently, see the data that is associated with these items, because typically you have data, and you can search it and then even explore it and send it to our other applications for editing, exporting, and so on. And yeah, so this is the Jupyter Notebook widget, and so this is not super impressive right now. When we built this tool, we were looking at what was there in the market, and we found that they were, well, pretty boring. So most of them didn't even like support labels, so they were really just for like scientists. They wanted to see the structure of the graph, but really weren't interested in single items. So we came up with this little widget here that allows you to actually do more than just show the graph, but also like style the tool, the graph. So here's a more interesting example. We're using the let's start up here. We are actually going to the web, downloading a JSON file from the web, and which has some graph-like structure in it. We're parsing it right here in the Jupyter Notebook into nodes and edges, and then we're configuring the widget and sending this one to the visualization. And so this is a hairball. It's super boring, and you can see like the neighborhood, for example, that helps you. So this is a separate view. It helps you navigate your data. So if you know that there is like a directed neighborhood, using this to really walk through your graph is super convenient, so even if your graph is a mess otherwise. But it doesn't have to stay that way. You can like specify a more sophisticated layout and come up with some styling. For example, we are using this web hook to fetch some images for the various nodes in here. We specify some color mapping. So this is just static mapping, but you can like dynamically define the mapping and map the data to the visualization. And let's see what this results in. So this is much more interesting, because this is like a supply chain. We can see how stuff what stuff consists of, and what stuff can be made of other stuff. And yeah, so this is from a little game, and we see that there's this visualization in there with the icons and the coloring and so on. Quite nice, actually, for just a few lines of code. And
there's a couple questions in the chat around this, if you want to take a couple of them.
Yeah, sure.
When using a pandas data frame as the source for the Jupyter graphs, are we required to define separate vertice and edge data frames? Looks similar to a graph frames data set.
There's two options. So one is to do it like basically what I did in here. So as you said, I was like transforming the data into two lists, basically into a list of nodes and then a list of edges, because that's the model that the visualization uses in here. So if your data frame has a different structure, so if it's, for example, it's not typically, but if it was something like an adjacency matrix, obviously there's not a list of edges and nodes, but it first has to be transformed. So we have a default. Let me find this. There is a default transformation for Panda data frames, but in the case that the structure of your data frame doesn't like match our expectation, then you can always like go down and either like import it into another tool like yWorks, which is really great at like importing data structures and transforming them into a graph, and then just pass on the yWorks graph to the widget, or manually transform the data. So here's the rules how we like parse the data frame by default. So if you can just like when you create the widget, you can just pass in the data frame and it will show the graph, but it will only be useful if it has this structure. So if your data frame doesn't have this structure, I think it should be a pretty common one. If you think differently, please do provide feedback, because it would be easy for us to like, well, support other types of data frames or like schemas. Then just like open an issue in this repository and make a suggestion or give us an example, and we'll see what we can do. But yeah, that's the these are the rules for the default structure. And if this doesn't work for you, either like pre-process the data or use Python to transform us into nodes and edges. I hope this answers your question. Yeah. Another one?
And then the other one, in a Jupyter notebook, can you do the styling programmatically or only manually?
The styling, you do it with like these callbacks over here. So there's various mappings that you can specify. Like, how's completion working here? Not this way. So there's various. How do I get the completion to work here? It doesn't pop up. So in the widget, you can. There's things like size, and color, and icons, and maybe I think it should say so here. Otherwise, I'll have to open the documentation. No, obviously not in here. And but you do this by specifying code. Actually, you can't do this interactively once you open the widget, so you can't change the styling interactively here, but you do have to use programming. So you have to specify those bindings over here, for example, to influence the size of the elements, the color, the thickness of the edges, whether there's an arrowhead, and icons, and so on. And there's a set of features that we support. Let's see, I think it's in property mapping. This should list most of the properties. No, not this one. Let's go back to the documentation. It's in here. And if you feel that there's something, also please file an issue, or maybe just send us an email and we'll see. But the documentation is actually quite complete. So if you feel like there's something missing, this might be just the case that it's missing. So sometimes it's we were hesitant to add more features to the API because we were both trying to keep it simple, and also, of course, we don't want it to be a complete replacement to our commercial library, because this is a free tool, obviously. So it's also a commercial decision not to put all of the features that we support on the library level in here. But yeah, you should be able to do this programmatically. with the bindings in the notebook.
Cool. One more here. Can we do clustering and classification using knowledge graph embeddings?
Very good question. Indirectly, yes. Not directly, but what you can do is you can you use any library that can calculate this information for you in the Jupyter Notebook, and then use the output of that library to feed it into the visualization. So, for example, I think I have an example where we are like using some I don't know, calculating some algorithms, some centrality algorithms, and then using those values to change the size of the nodes in the visualization. So this is actually running the algorithms in Python, not the ones in Y-files. This widget doesn't give you access to the Y-files algorithms programmatically. So this is really just a super small set of functionality that we provide here. So it's not your it's not meant to be as not nearly as extensive as the Y-files library. So it's really just a very small feature set. Yeah, let me know if you think there's something missing that we should be adding right into the widget. But otherwise, please check out the examples for the, I think it's in the, yeah, one over here is the Neo4j sample GDS, which actually uses the Neo4j graph data science library to calculate some graph data algorithms, large scale ones, and use this to actually render to use the output of these algorithms for as input for the styling in the rendering. But I think there's more I think in some Network X examples. I will check later. Maybe I can just send me an email and I'll get back to you with some links for those specific ones.
Yep, cool. I think we can keep going. There's one other in here, but I'll save it for
later.
Keep moving. Yep.
Okay, perfect. So let's get back. Where's my presentation? Over here. So I guess that's the Jupyter widget, basically. Now that we've covered this and we've seen how we can use the Data Explorer and the Python plugin, let's just go one step further and it's still use a low-code tool to actually build an application. So because while some would say the Jupyter Notebook is almost like an application, but there's much more that you can do when you really start programming, as you probably know. So this will actually unlock a whole new level of possibilities, as you will hopefully see right in a minute. So, but I won't go too much into the details and keep this short. So the app generator, as we call it, is a low-code tool for scaffolding source code of graph visualization apps and reusable components for you to integrate into your applications or to build new applications from. So it's also hosted online, and you can try it without downloading. So what does it do? It's again, it's an application, and this is very meta because it's also using graph visualization to configure the application. But this is not the graph that we are ultimately interested in. So what we see here when we start the application, we start with a blank canvas, and what we can do here is like we can move elements onto the canvas, and we can then like connect them. And the idea is to, if you do it properly, of course, and the idea is to come up with a flow that describes how you extract your data from some data source and transform it into a graph. Let's take a look at some of the example projects that we have in here, and it will be much clearer then for you, I guess. So I thought, because I wasn't able to provide you with some Sparkle Explorer, I thought I was going to show you this example. The flow right here is basically from left to right. So these are our data sources, our inputs basically over here. and then the data gets transformed, and in the end we get a graph. And how does this work? So we have some like predefined function nodes in here, and this one, for example, is a Sparkle loader. So what it does, it allows you to connect to some data source. In this case, it was configured to go to wikidata.org to the Sparkle endpoint, and it does an HTTP GET, and then performs this Sparkle query here at the bottom. So that's a pretty generic query. And so once this runs, we get back some data, and we can inspect the data over here. This is basically just JSON data. And as you see, these are like triples or top tuples of data matching my query. And in this case, what we're doing is we're like running a kind of like a projection of the data to only get to to get it into a format that works nicely with these nodes in the end. So what we do with these function nodes in the end. So what we do is basically we have two flows over here, and this one at the upper hand like feeds into this node, which tells our builder object in here which items to render as nodes. So we see if we go here that in the end there should be like about 1,000 nodes in the visualizations, and these are the various nodes in there with the various properties and values. And I can like generically configure how I want these nodes to be styled in here, and what labels they should have. And of course, in order to make this a graph, I also need to specify how edges should be loaded from the data. So what I need to do in here is I tell it in the data where to find the information about the source and where the target is of all the edges. And this is also piped in here. So we have nodes and edges, and then we apply an automatic layout, in this case, the organic one. And then we should see the graph in the end once we execute this flow over here. So and I can hit this button over here, and then it will execute the flow and come up with this graph visualization. And so that's not super interesting right now. The cool thing about this is the button here below, which allows you to actually create a source code bundle for the application that I just created, basically by plugging together these various nodes in here, these functional nodes in here. So when I do this, I get the option to specify what kind of application I want. So should this be a Vue-based application or a React application or an Angular application or just vanilla JavaScript without any framework, or even a reusable React component that I just want to integrate into my application. And I can do this. Let's just, I don't know, choose this one, React, and then it lets me specify what language it should be in. And then I can choose some features that I want in my application. So like I want a context menu, an overview, and the search bar, tooltips, and so on. And once I hit download, it will go and build this file for me. And this is a zip file that I can just open in my IDE, run. This is a web application, so I need to like run npm install and then npm run. And then I will get to see basically what I saw in here, this as an application. But the beautiful thing is that this is source code that I can actually modify. So this is source code that's easy to read and nicely structured. I hope so that you will like it. So there's various components and the features that we have in, so it's all pluggable. And of course, it's hackable because, well, even though we were able to create an application this way, there's so much more features that yFiles has to offer. And of course, we don't have all of them covered in the UI. So there's definitely things that you can't do in here. There's actually way more things that you can't do in here than you can do. So, but this is great for getting started quickly, for playing with the various data sources. As you've seen, there's many different sample projects that that might match your situation, and you can combine them. So you can load JSON and CSV files and XML at the same time, fetch them from some REST API, transform them into a graph, and load this into a visualization. And once you export this to the source code, you can like modify this and build upon this. So you use it as a scaffolding tool to get started quickly, as a low code tool, because it's not no code, it's low code. There's some things that of course are code in here. So like here, there's some snippets in there that will later be embedded into the generated source code. But it helps you really get started with your yFiles powered component or application, because well, we basically we built this. One of the reasons we built this was really because everyone likes different framework, everyone has a different kind of data source, and so the matrix of possibilities gets so big that we didn't want to like create 10,000 different sample applications, and rather we came up with this generic tool where you can plug in your specific data source, tell it what's your favorite application framework that you want to use, and then you can get started with the code in your IDE. But once you are in the IDE, then you can tap into the whole world of yFiles applications that you and all the features that you get if you look at the demos that come with our yFiles package. They are built in a way that you can just like copy the features that you like into your application and combine them in a way that are unique to your use case and that help your users get those insights into their application, into their problems easily.
Wow, powerful stuff.
Yeah, so just let me quickly end by showing you the demos that we have, because they are actually probably far more impressive and provide you with more examples on what you can do than I can show you here. So go to yfiles.com/demos, and this will lead you to this page. And there's some like curated examples. So there's a quick tour, and you can check all of the items in the quick tour, which are probably the most high level introductory examples that we have. But there's actually, if you like, if you use the search, you can see that there's almost 360 different demos showing what you can do with the library. And so these demos cover very complex use cases, but also smaller aspects of the library, things like integration, showing various features, showing how to integrate yFiles with frameworks into your application, with loadings and data sources, and so on. And all of these demos come with full source code, and we actually have it on GitHub too. So if you're interested in a certain feature, you should be able, and that's at least that was our goal, to like just copy that part of the application and paste it into your application, maybe the one that you scaffolded with the app generator, and then plug together those functionalities that you're interested in and create something awesome. Yeah.
Wow, cool.
So I think that's almost all of what I had prepared. There's one thing more I can show you for the programmers of you. We have this yFiles playground, which is yfiles.com/play. Let me just quickly show this one. So if you go to yfiles.com/play, you don't have to like download our library. You can just like try it out in your browser. This is a super mini Visual Studio Code instance running right in your browser, so it's not leaving your system again. And you can there's a couple of examples in here that you can use as getting started feature, and it allows you to like explore the API, understand what properties are in there, what properties can I set, and so there's there's the documentation for all these properties in here, so you don't have to like boringly read through the API documentation, but just try it out and then execute the code and see how this like influences the results. So if I like change the layout orientation, obviously what happens if I say top to bottom, just see how this affects the layout. So there's very simple snippets in here. You can try them out. No need to download, no need to store. You might be even able to do this with with your mobile phone, but if your screen is large enough. But a really super low barrier to try it out and see what you can do with WAV files. But yeah, the recommendation, of course, is to download the package, which you can do for free for initially just 60 days for free. But I can tell you that if you need it longer, just drop us a message and we'll prolong that evaluation for you, because we know that typically, I think our current like lead time, not lead time, the time from evaluation to buying typically is like, I think 6 months on average. So 60 days is typically not enough, and we're totally aware of that. So just go ahead and try, and if you run out of time, let us know and we'll find a solution. Typically, well, just prolonging the evaluation.
Yeah. Michael Ushold, quick question. Oh, you're muted too.
Sorry, thank you. Yeah, you mentioned property graphs is what you're using at the moment, but that you're working on Sparkle. I'm wondering, once the Sparkle version comes out, are there going to be any important differences, or is it more or less the same functionality?
Very good question. We initially we were hoping to be it almost the same functionality, and but we found that there's some conceptual differences which made it difficult to be exactly the same features. So well, we have this schema view here in the Data Explorer, which is not as easy to parse from our Sparkle database typically, because there's so many different ways people organize their database that we found it hard to come up with, well, a generic mapping from the database to a good visualization. So many of the things need to be like, well, you kind of like need to specify how you want them to be represented. So as I said before, do you want certain properties to be represented as nodes or just as properties of the elements? And this is something that you typically can't automatically infer from just by looking at the data. So this is what we found is the most challenging. So we were thinking about doing it exactly the same way like this, and most of the features are exactly the same, but specifically the mapping from the data to the visualization is something that we haven't quite solved yet. So if we are actually looking for like real world example databases or at least schemas, so we're not really interested in the actual data, but how you guys or our customers or users actually structure their data and how they would like to see it visualized in an Explorer. So I can provide you with access to this thing, to the Sparkle version of it, and you can just try to read your database and see what happens. And if it doesn't work, specifically if it doesn't, let us know and tell us what's different about your database. So specifically, the features working with the schema aren't working as nicely as with the Neo4j one, where there's, well, more like an implicit schema available than you typically see in a triple store database.
Thank you.
Yeah, we should maybe talk more on that offline, Sebastian, because there may be a number of folks at Semantic Arts that might want to sort of play around with that option a little bit. So, Michael included. So good. Well, I know we're a couple of minutes long. Would you be able to share some slides and links with me? And then later today, I'll send out this recording to everybody, and I can include whatever you'd like me to with that for follow-up.
Yeah, sure. I can just like send you PDF of these slides in here, and yeah, we can just share them. Yeah,
Cool.
absolutely
Yeah,
fine.
very good. Well,
I think we already arrived at this slide basically. So, but if there's any other questions, of course, I'm happy to answer them now, or you can just like contact me. You probably seen my email on the invite, but yeah, if you haven't, here it is. It's the canonical one. My name at yWorks.com. I'm also on LinkedIn. If you want to connect, feel free. I'm happy to accept your connection requests. Yeah.
cool. Very good. Well, thanks for joining. We had a couple comments in the chat of people who have already been using some of the different tools and really like them. So this was great, and I will get recordings and info out to everybody later today. And yeah, really appreciate your time. Look forward to seeing everybody next month.
Thank you so much. Thank you for
Thanks,
listening, and have a good one.
You too.
Goodbye.
Bye.
Thanks.